Welcome to Scaling Up, the podcast for water treaters by water treaters, where we're scaling up on knowledge so we don't scale up our systems. Hi, everybody. Trace Blackmore here. I am the host of Scaling Up, and you know as well as I do, as a water treater, you have to know so much stuff. The list is never ending. Well, today's guest is Chris Nagle of Evapco. Chris has a very unique perspective because he's a water treater, but he also works for Evapco, which is a cooling tower manufacturer. Today, Chris is going to talk about all things white rust. And if you don't know what white rust is, I promise after today, you will know. And he's going to talk about all the things that Evapco is doing to help solve this issue. The simplest definition of white rust is the galvanizing coming off of the cooling tower. Now, galvanizing is a coating of zinc over the steel surface. This is done so the zinc can corrode instead of the steel below it. This is called a sacrificial anode. We sacrifice the zinc, which is anodic, so the steel can be protected. Once the zinc is gone, the steel will then begin to corrode. Now, white rust is the premature corroding of that zinc. Now, folks, as a water treater, we get blamed for everything. I remember a conversation that I had with a customer that said they never had bulbs burn out until our company took over their water treatment. So what that means is we are not doing a good job of explaining what water treatment is. That's a soapbox for another episode, but we're talking about white rust now. And white rust is an issue that is normally blamed on the water treater. In fact, some of the cooling tower manuals state consult your water treatment provider for concerns on white rust. They just put all the responsibility on us. Or they state some ridiculous water condition that needs to be maintained in order to prevent white rust, something that is nowhere near normal operating conditions. Evapco has done a great job in working with individuals like myself and others in the Association of Water Technology, gathering information about white rust and also testing that information and exploring new ways to deal with it in their units that they have set up in their home office. So I hope you enjoy my interview with Chris Nagle. My lab partner today is Chris Nagle of Evapco. Chris, how are you today?
I'm doing well, Trace. How are you?
I'm doing very well. I want to thank you for being on Scaling Up, and I want to thank you for getting ready to tell us about the topic that most water treaters want to know about. What do I do if I get a brand new cooling tower that happens to be galvanized?
Happy to help. Glad to be here.
So, Chris, you and I have known each other for years, but there may be some people out there that aren't familiar with you. So do you mind maybe giving us a brief synopsis of who Chris Nagle is?
Sure, I'd be happy to. I've been fortunate to be married to Brenda for about 27 years now, Trace, and we've been blessed with two terrific children. And if they were here with us, they might not like the term children because they're probably young adults at this point. Our son Richard has recently joined the Navy to serve our country and is today on his way to Charleston to enter the nuke school there. And our daughter Julia is getting ready this coming Friday to head back to Boston College, where she's pursuing an undergraduate degree in, well, we don't know, undeclared, but an undergraduate degree at Boston College.
Well, excellent. Well, Chris, I know you've been in the water treatment industry for quite a while. Can you tell us how you got involved in water treatment?
Well, in one sense, I was born into the business. Both my father and my grandfather worked for Betts Laboratories. So as a young boy, I remember my dad bringing home Betts's mobile lab and getting to play in the lab. It was like in an RV or a camper at that point back in those days. And then following my father's retirement from Betts, I joined Betts as a sales and service rep in 1994. I was very fortunate to learn the business from some great area and district managers at Betts. Over the years, I earned several promotions and sales awards during my career with Betts Laboratories, Betts Dearborn, and of course GE Water and Process Technologies.
So it's safe to say that you're not just a corporate Evapco guy. You know water treatment. You are a water treater. You're one of us, and you understand what we go through day in and day out. Would you say?
I'd agree with that, Trace. And even though I'm in an office most days now, I did spend 13 years in the field doing sales and service and working my way up through the area manager position, the district manager position. And when I left GE Water and Process Technologies at that time, I was a territory manager with about 28 direct reports. And I think at that time we had about $40 million in business between the chemical side and, of course, the RO and high purity water side of the business. So I've done most everything from taking water out of the river to anything you might do in a process with it to putting water back into the river.
So how did you come to work for Evapco?
Well, that started in 2006 when I was working in Philadelphia, and I had an opportunity to meet Bill Bartley, who's our president and CEO. And in 2006, Evapco had started to promote some water treatment systems. They were early on, and they were looking for somebody with some industry experience to come in and help them understand not only water treatment technically, but the marketplace and how they might be able to grow their water treatment offering from where they began at that point.
What would you say the biggest differences are between working in the water treatment field and now being where you are now with Evapco?
Well, if we had video with our podcast today, Trace, one of the biggest ones you'd notice right away is that I wear a tie to the office every day.
I'm sorry, what is that device you just spoke of?
A necktie, which is certainly not recommended for mechanical rooms and field work. So that's one of the differences from dress code. But other than that, the biggest difference is when I go to the office, I'm not going to a home office like most of the water treaters in the field would do. And then most water treaters in the field will log a lot of miles, windshield time perhaps, driving to customers and that kind of stuff. My travel tends to be a little bit more airplane based. So I'm traveling across North America, Western Europe, and parts of China when I'm not in the office.
So you've hosted me a couple of times, and I've seen your facility, and it's incredible, some of the test rigs and things that you're getting ready to tell our audience about. But I'm worried now. I didn't wear a tie. Were people thinking poorly of me?
No, most of our guests, whether they're customers or representatives, they're engineers, contractors that come visit us here at Evapco, have a little bit more casual dress code than lingers here at Evapco headquarters. We're based outside of Baltimore, not too far from Gettysburg, PA. And at our headquarters here, we not only have our corporate offices and a full manufacturing plant, but we also have all of our research and development laboratories where we do a lot of the discovery to improve our evaporative cooling equipment and also our water treatment systems.
Well, let's start talking about some of that. So today's episode is about galvanizing and what happens when galvanizing starts to fail. So but before we go into that, do you mind explaining what really is galvanizing?
Well, I'll try. It's galvanizing is a process where zinc is added to a steel substrate. So for evaporative cooling, galvanized equipment has been the preferred material of construction for over 50 years. And the reason for that is it's got a great first cost position, and it also can give excellent service life when properly passivated and treated. So there's two types of galvanizing that are most typically found in evaporative cooling systems. The first would be mill galvanizing, where the zinc layer is put on to strip steel in a manufacturing process. So if you think about a cooling tower, the basin or upper casing section might be made out of mill galvanized steel. The other type of galvanizing that's common in the industry is called hot dip galvanizing. And you would see this more often if you were looking at a closed circuit cooler or an evaporative condenser that has a coil bundle in it. And what happens from a manufacturing standpoint is the coil is made out of stainless steel. It's pressure tested to make sure there are no leaks in the coil. Then it's sent to a galvanizer where the whole coil is immersed in a molten zinc bath. And that's the hot dip galvanizing process. The difference between mill galvanizing and hot dip galvanizing is you tend to have a thicker coating on the hot dip process, so on the coil, than you would on the mill galvanized that's typically used for tower basins or upper sections of towers or coolers.
So what is the issue? Why did Evapco say we've got to do something about this galvanizing? What was happening?
Well, with galvanizing, if it's allowed to cure, so to speak, in nature, or if it's allowed to sit for an extended period of time, it will naturally passivate itself in the atmosphere. The challenge in industry today, as you probably realize, Trace, is lead times have become shorter and shorter and shorter. This just-in-time society we live in means that a lot of equipment that we're making now is being put on a truck, sent to a customer location, rigged, and started up, sometimes in less than a month's time. So the bygone era of us building equipment and it's sitting in riggers' yards and getting exposed to the atmosphere and the elements has gone by the wayside, and particularly in the industrial refrigeration space. So these would be the guys that are running evaporative condensers, where on the inside of that coil is a refrigerant like ammonia or CO2. When they're running food processes for either production or cold storage, they can't have their plant be down for very long without maintaining the temperatures they need for their processes. So they tend to start this equipment up very quickly and under immediate heat load. And one of the things that started to happen in the late 80s or early 90s is a new phenomenon that was called white rust. And that's a form of premature corrosion of that protective galvanized zinc layer.
So that's the actual galvanizing separating itself from the metal.
It's actually, separating might be one term. I like to think of it in terms of kind of exfoliating, because it'll be a highly localized reaction where the galvanized zinc starts to corrode prematurely, and it'll usually become a white, voluminous, sometimes jelly-like substance that is really an indication that that protective zinc layer is being compromised or corroded prematurely. And obviously the concern, besides just the unpleasant look of it, is that by losing that protective zinc layer, we might shorten the service life of the equipment.
So I'm guessing that Evapco probably got some phone calls saying that we bought this brand new tower and now the galvanizing's coming off, and what are you going to do about it? Something like that?
That's true. We did get calls and questions and concerns, and we do have technical guidance on the subject in our equipment IO&M, or installation, maintenance, and operation manual. And in a lot of the research and a lot of the guidelines early on related to white rust and passivation, the recommendation was to start the equipment without that heat load. Obviously, our customers in the industrial refrigeration space can't do that. So their question for Evapco is, what can you guys do to help us minimize white rust for this new equipment that we need to start with immediate heat load?
Well, I've got to commend you guys, because most people's reaction to that question is, well, when in doubt, blame the water treater.
Right. And for years, you're absolutely right. When I was with Betts in my early years here, whenever white rust would occur, there was this kind of pointing of fingers where the water treater might want to blame the galvanizing process or the equipment manufacturer. And the equipment manufacturer might want to say, well, maybe the water treatment guy didn't do a great job with the passivation, or maybe their chemicals are causing it. And then something happened along the way. As Evapco got into water treatment, we became both sides of that argument. So that's when it really hit us that we need to help move the industry forward by researching this and seeing what we can do to learn what causes it, and what might minimize it or lessen the chances of a customer ending up with white rust.
Well, let's talk about that process because you guys have a great lab. You have all these test towers that you're testing these very items. So can we back up a little bit? And you guys know you've got a problem. And now you said, we're going to figure out what we can do about it and then let the industry know some better procedures. How did you start that? And then what did you do?
Well, we started that based on a lot of research, and we went looking for a lot of papers on white rust and passivation. As you probably know, AWT is a great source for that kind of educational information. And when we started reviewing the documents, a couple things struck us. First was that a lot of those papers were written in the late 80s and early 90s. And there seemed to be a little bit of a gap more recently where there wasn't a lot of research or talk about the problem, even though most in the industry would agree it hadn't been solved or resolved. The other thing, so from that research, we started with some benchtop testing. And in a lot of those papers, you'll read about people using corrosion coupons and studying the impact of different processes on the corrosion potential of the coupons. And we started down that road, but we also had the advantage of being a manufacturer. We could build some units and try to see if what we were seeing on the coupons worked well on operating units. And early on, we identified that coupons, even if we heated the beakers or aerated the beakers, were usually look better than an actual operating unit would. So that means this benchtop testing that we undertook at the beginning usually made the problem look easier to solve than what we would see when we would take it to a unit. And what we attributed that to was the fact that with the coupons, the most you can do to simulate a heat load is to heat the bath, the water in the beaker. But in operating units with coils, the heat is actually coming through that coil and coming through the galvanized layer to come in contact with the water. And that's a completely different impact on the surface of that galvanizing. So it took us about a year to realize that we really couldn't rely on coupon type testing or benchtop type testing to try to figure this complex problem out.
It really is impressive, the rigs that you set up. And if it's okay with you, I'm going to put some of the pictures and the abstract that you presented at AWT on my show notes page.
Yeah, that would be fine.
All right. Well, now you mentioned earlier, we're talking about heat load. So why is that such a big deal? So, everybody's worried about how much alkalinity they have, what the pH is, and now you're throwing this new variable in, the heat load.
Yeah, that's a great question. And early on, when I would talk to water treatment guys about the problem, I'd always ask the same question: what's the most important parameters? And I won't say 100% of the time, but the vast majority of the time, experienced water treatment guys would point to the pH or the alkalinity of the tower water or the spray water. The other thing we learned about that along the way was most water treatment people will refer to all evaporative cooling equipment as a cooling tower. And in the equipment field, it's quite different because we'll talk about an open cooling tower in terms of one that has a fill where the water comes through the fill and comes in contact with the air and is cooled and everything happens there, as opposed to the closed circuit coolers and the evaporative condensers that I mentioned to you a little bit earlier that have the coil in there where the heat transfer is actually occurring across that coil. So the reason the heat is important is because white rust is a form of corrosion. And like most corrosion reactions, the hotter you make the surface, the faster the corrosion reaction wants to occur. So for that reason, I would suggest to our friends in the water treatment community that having a site-specific passivation plan is even more important when you're treating a closed-circuit cooler or an evaporative condenser than it is when you're treating an open cooling tower, because the temperatures at that coil water interface tend to be higher on a coil product than they're going to be in an open cooling tower.
Now, in these test units that you mentioned, I know you weren't just running one type of water. You had many types of source waters, and you created synthetic water, and you put different products in to see what would work better than something else. Can you speak to that?
Sure, be happy to. So when we started our research, and that's about 5 years ago at this point, we thought, well, we're pretty smart. This should be something we can figure out. And as we got into it, we learned there are a lot of variables to consider. So what we tried to do was build multiple test rigs where we could change just one variable at a time to see what the impact of that was or is. Early on, we tried to use Phoenix, Arizona water as our test water because we know that area with high alkalinity, high chlorides, and relatively high hardness is prone to white rust. And we got a little bit ahead of ourselves, candidly. We had to back down from there and start with some easier waters to get some success and build back up. So at our in our little test area, our lab area for passivation here, we have the ability to blend RO water with Town city water to make a lot of different blends. And then we've also done testing where we will add specific things like chlorides or sulfates back into that mix to make the water more aggressive towards the new zinc coating.
So from all of that, let's say a water treater is walking out, they're on the roof, and they see that brand new shiny cooling tower that just appeared. Nobody told them about it. And they now have to do something about it. What would you advise them to do?
Well, the first thing I would advise them to do is notify their customer in writing that a site-specific passivation plan is recommended. Whether it's an open cooling tower where you might be more focused on pre-cleaning the iron pipe so it'll accept inhibitors, or if it's a galvanized coil where you're worried about the coil bundle. The first job, in my opinion, of a water treater is to notify their customer and or their contractor in writing that something needs to be done. From there, the next step would be to identify what type of equipment am I dealing with. Is it an open cooling tower? Is it a closed circuit cooler? Is it an evaporative condenser? And how soon are they going to need to reject heat from that piece of equipment? We found that sometimes if we talk to contractors early in the process, they may be able to get an extra week or two of circulation of water without heat load if they just rearrange their construction schedule a little bit. And that can be a real help to the water treaters because the first 6 to 8 weeks of system operation are going to be most critical. And in my view, the first week is more important than the second week, the second being more important than the third week, etc. So any amount of time you can get to passivate with water circulation before heat loads put on the system, the better your chances of minimizing white rust.
So as far as the water chemistries, how much should we let it concentrate up to? What type of passivation material should we look into using?
That's a great question as well, because people say to me, what's the best procedure for passivation? And it's really can vary quite a bit. Early in our research, we took a look at a lot of the articles that were out there, even some written by equipment manufacturers that suggested high levels of phosphate or orthophosphate might be beneficial in forming the passive layer you were trying to form. Our research hasn't substantiated that, and my conclusion, which may be incomplete at this point, is a lot of that research or a lot of those articles were more for open cooling towers where the original intent was to get oils and grease and mill scale out of the piping and passivate the mild steel piping from flash rusting prior to treatment, as opposed to forming a passive layer on the galvanized surface in a tower or in a closed circuit cooler. So certainly pH and alkalinity play a role. We've also found that chlorides plays a bigger role than sulfates do. So my advice would be to look at the guidelines and then look at your makeup water quality. In some areas like you are, Trace, in Atlanta, it may be a lot easier than Indianapolis or somewhere else. Areas with high alkalinity and high chlorides are going to be the most challenging and require the most advanced plan. And there's some other areas where just by the nature of the makeup water, it's not nearly as challenging.
So, are there specific chemistries that you would recommend that would help, say, water in Arizona versus a water in Atlanta?
Well, that research is still ongoing a little bit. We have seen, or we believe we have seen, that azoles will inhibit white rust. We're not certain at this point that they will aid in the formation of a passive layer. So it may be a product, and there are some products from different companies on the marketplace that are white rust inhibitors, where they will inhibit white rust, but if you stop feeding them, you're still prone to white rust forming after the feed is discontinued. I would think that azoles fall into that camp. And certainly our research would suggest that having a good polymer in your formulation and keeping the surface clean aids in that passivation. From there, there's probably a couple of different chemistries you could look at to try to get either some anodic or cathodic corrosion protection in the mix.
So, are there any magic numbers that we shouldn't exceed this much alkalinity? We shouldn't exceed this much chloride or this pH?
I think probably so. Most of the literature you'll read will say that during the passivation phase, you want to keep the pH below 8.3. I'd suggest being a little bit more conservative than that if you're dealing with coil products, as the local pH at the coil water interface may be higher than your bulk water pH. So in our research, that seems to equate, if we're trying to stay, let's say, between 7.8 and 8.0 pH, and we're doing pH adjustment, in most waters, that tends to equate to somewhere around 125 to 140 parts of alkalinity. But as you know, that can change from location and water source a little bit. Chloride certainly higher makes it more challenging. We haven't got to the point in our research where we've found an absolute upper limit, but certainly if you're in areas with very high incoming chlorides, it can make the problem more challenging. The other thing that you want to think about besides the type of equipment and the water chemistry, in my opinion, is to make sure that your contractor or your customer know that minimizing white rust is a team effort. And by that, I mean the water treater is not going to be there every day operating the plant. So either the contractor or the customer, or hopefully both, need to have a site contact that you can reach out to and get on the phone and check in and see if there's any alarms or any of the inventory is running low or any upset conditions. Because without that local support at the plant, it's very difficult in a 6 or 8 week period to be on site enough to ensure treatment success.
I think that's great advice. And when you're communicating like that with your customer, they realize that it is a concern. And it's normally when you don't have those conversations with their customer that they try to point the finger when something doesn't happen correctly.
Right. And unfortunately, that step of not documenting things can come back when there is a problem. People are going to say, well, did you tell me? And as you probably know, if you've told them in writing, it's a lot clearer and easier to explain than if you've had a verbal communication with one of the operators.
Absolutely. Do you ever recommend acid in passivation?
Recommend may be a term that's a stretch, but we do use acid in our passivation process in the field when it's appropriate. The one thing I would suggest to your audience is don't try to do pH control or acid feed on the cheap. We've seen many systems ruined by short duration acid overfeeds. The problem with acid feed as it relates to passivation or ongoing treatment is overfeeds that depress the pH rapidly can cause damage very quickly. So, the new zinc will tolerate pHs between 6 and 8 very nicely. As you start to go below 6, then you start to put the the galvanizing itself at jeopardy. And we've seen examples over a weekend where somebody's tried to feed acid on a timer or without good feed and control mechanisms in place and have fed too much acid, and excursions have occurred below 4, and they burn the galvanizing to the point that the system's compromised. So in those situations, in those areas where pH control is the only way to maintain your pH and alkalinity, we strongly recommend having good feed and control and making sure that you're feeding to a point where you have good mixing and you're getting pH measurements and alarms at an area that's representative of the system.
So it's safe to say that the acid feed failures you've seen is because people just trying to do it cheap, as you mentioned.
That's usually the case, that they just haven't invested, whether it be the customer or the contractor or the water treatment provider, haven't invested in the correct or the necessary feed and control equipment to make sure that overfeeds don't occur. And the challenge, Trace, is that the damage done by an acid overfeed of even short duration, a day or two, can be far worse than the white rust that we're trying to minimize as far as equipment service life goes.
You know, that's a great point. And I know some mechanical contractors will come in and they'll clean off all that white rust to try to get it nice and shiny again. What do you say to that?
I don't recommend it personally. If you think about it, that white rust is premature zinc corrosion. So if you remove it, you're speeding up the process of losing the galvanized zinc that you want in the unit. It's also problematic when we think in terms of the coil products like coolers and condensers, because it's very difficult to mechanically clean down into that tube bundle. You can't fit down in there. And even when we're thinking about trying to clean up scale from those coil bundles, which is slightly different, we need to be very careful how we portray that to an owner, because I will suggest to your audience that if I clean a scaled coil to the point where the bottom of the coil is visibly clear of scale, I will almost certainly have burned the top of the coil, because the reactions are going to start at the top, at the spray header, and work their way down through that coil bundle. So I'm not a fan of removing white rust once it's occurred. My recommendation generally is to monitor zinc residuals in the water and see what your trend is telling you. If your zinc levels are stable or going down, that's generally indicative of a stable system that's not getting worse. And as long as your zinc numbers aren't continuing to climb, it's probably better for the equipment to leave the white rust, even though it's visually unappealing, than it is to try to remove it from the system.
Are corrosion coupons, like a zinc corrosion coupon, important to have in the system during that first 6 to 8 weeks?
My answer would probably be no. And the challenge with any zinc surface is to have it be representative of what's going on in the larger system. So certainly we all can understand that new zinc, whether it's on a coupon or in a system, is going to be more reactive than the zinc that has been there a while. So could it be useful as a trending tool? Perhaps. Do we recommend it be part of every passivation plan? I would say no.
So use it as data, not the end all be all.
Yeah, I think that's really what coupons are good for, is to give you a trend and give you data. And certainly if you have an established treatment program and you want to change to something else, having that coupon data is very helpful to see if you're staying the same, if you're improving, or if you're getting worse.
Well, we talked about some really harsh waters like Phoenix, Arizona. And so I've got water in Phoenix, Arizona. It's very harsh. So now I've got the options of either I can add acid. Maybe the customer doesn't want to spend the money, so I can do that properly and I feel comfortable about it. So now I've got to set the bleed. So we're going to be wasting some water in the beginning so we can set up that galvanizing to have that nice passive film. Is there ever an instance where the amount of water being used outweighs the mechanical benefit to the actual passivation procedure?
Well, that's a good question. I would say that in many cases, bleeding more water and maintaining lower cycles can be a sound strategy for passivating a new unit, obviously depending on the quality of the makeup water. The two caveats I would give to that is, again, it goes back to documentation. You're going to need to notify the owner and the contractor in writing that going down that road will use substantially more water, because we see a lot of customers after the fact complaining about water usage in that kind of scenario. And the other one is that it depends quite a bit on how hard the unit's being run. So again, going back to that distinction between an open cooling tower, which tends to be a relatively large volume of water with relatively low turnover rates, versus a cooler or a condenser, which is a very small volume of water with very high turnover rates. If you have a cooler or a condenser that's under some amount of load, it's going to be very difficult to maintain low cycles of concentration with that unit running, rejecting heat, and evaporating water.
Chris, how much longer will a properly passivated cooling tower last over one that was not properly passivated?
To answer that specifically is quite difficult.
Sure.
But I will give you some anecdotal answers to that. My view of equipment lifespan is if a galvanized piece of equipment is passivated correctly and maintenance and water treatment are maintained consistently, that having a service life of 15 or 20 years is certainly achievable in many parts of the country. I'll note when I say that at events in front of customers, sometimes somebody will say, well, I have one that's 25 years old or 30 years old. Which is probably true and achievable in other parts of the country. I would question then if the energy efficiency and the design of that unit's up to current standards. On the flip side, several years ago in 2010, I was fortunate to give a talk at IIAR, which is the Ammonia Refrigeration Conference in San Diego. And I suggested to some of the contractors there that stainless steel might be a better material construction in some markets or with some water qualities. And after my talk, a gentleman came up and was discussing the cost ad associated with stainless steel. And I asked him where he was operating, and as luck would have it, it was Phoenix, Arizona. And I asked him in Phoenix, Arizona, how often his customers were typically changing out condensers, and his answer was 7 years. So certainly we have seen cases on zero bleed and other systems where a lot of white rust can occur very quickly, 90 or 120 days. I would say that most even somewhat abused systems should be able to get you 5 to 10 years, and well-maintained should be able to get you 15 or 20 years.
Well, let's go back to that water treater that instead of finding a brand new cooling tower on that building, they have a great dialogue and relationship with their customer. And the customer asks them, what do you recommend for our next cooling tower? What would you recommend they say in that conversation?
Well, there's so many options out there today between hybrid coolers and open cooling towers. So you really want to start with the area, the part of the country or the part of the world you're in, and what their design conditions look like. And then you want to look at the customer's process. Does it make sense for them to have the cleaner process water associated with a closed circuit cooler, or is it feasible for them to run tower water to their process? From there, it becomes a question of the makeup water quality available. In many parts of the country, you can get 15, 20, 25 years out of galvanized materials or construction, and obviously they're going to cost a little bit less up front. On the flip side of that, there are areas where it's going to be very difficult to passivate, and so it may be worth investigating whether you want to go to some stainless steel, whether it would be 304 or 316 materials of construction, and the costs of doing that have come down substantially over the years. So we're seeing more and more customers that are at least investing in stainless steel basins and then deciding on their other materials of construction from there.
So, and has it been your experience when you can explain with a customer that even though the basin being made out of stainless steel is more expensive, you can show the ROI and show how things are going to last longer, and In downtown Atlanta, you're not just putting a cooling tower on a building, you're getting a helicopter or a crane and closing down a street. So there's a lot of other expenses that people don't necessarily equate with that. Has it been your experience that people normally appreciate that and say, yes, that makes a lot of sense?
I would say that more and more customers are heading that way, Trace. As you know, in your business or any of the other water treatment businesses out there, there are some customers that are going to be low first cost customers. But I think more and more customers today are looking to their service professionals, like their water treatment provider, to give them options and to give them alternatives to what they may have done in the past. And your point's an excellent one, where it's not only the cost of the equipment, but it's the rigging, the getting it on the roof. We see projects where they're buying things knocked down because they have to take them up in elevators, or the helicopter lift that you mentioned. And, in areas like Los Angeles, going to a higher material of construction, in that case, 316 stainless steel, they can actually run higher cycles of concentration and save some water versus the other options on the market. So I think the trend is certainly in that direction. But in any sales situation, it's difficult to say that 100% of the customers are going to take that kind of advice.
Answered like an attorney. How about that? All right.
I have not been an attorney, and I didn't stay at a Holiday Inn Express.
There you go. I was waiting for that one. What is the biggest mistake that you would say water treaters make that they need to stop doing when it comes to passivation?
Well, I may have touched on these, but I would give you three as opposed to one biggest one. And the first one is that documentation. Make sure that you explained why it's necessary and that you recommend it to your customer or to your contractor in writing. The second mistake I see is some folks will treat a cooler or a condenser like a cooling tower, and they're mechanically different and probably from a chemistry standpoint need to be thought about differently. One idea I'll give you there is because of the high water turnover in a cooler or condenser, using a slow-acting or long-duration non-oxidizing biocide is probably not as useful as something that like DBMPA that'll act a little faster, because the retention time in those systems is different than an open cooling tower. And then the third one I would say, again, is related to pH control. Either do it right or don't do it, because your risk of trying to do it with either inexpensively or on a low cost solution without proper feeding control, you're taking on a lot of risk.
Well, if one of our listeners wanted to learn more about white rust and passivation, what advice would you give them?
I would have them start at the AWT website. I know AWT updated their paper or guidelines perhaps on the subject in 2012. Also, the Cooling Technology Institute has a paper from 1994 that's a good primer on the subject. And for those that might want to watch a video, Evapco has produced a educational video that can be found at www.evapco.com. And if you go to our website, there's a link at the top for videos. And if you click on that, in the bottom right, you'll find a video entitled Understanding Passivation and White Rust, which was really designed to explain to contractors and owners the importance of passivation to minimize white rust, and also shows some of the test equipment and some of the research that Evapco has been doing on the subject.
Well, with your permission, I'll put that on the show notes page as well, make it real easy for people to find.
That would be fine. We'd be happy to. I believe it's also available on YouTube.
And I got to tell you, as a water treater, I know you and I have a lot of dialogue around this topic and other things water treatment related when it comes to cooling towers. And of course, all the other things you guys call cooling towers. Right. I always learn a new acronym or something every time I talk to you. But I really want to thank you for not being one of those folks that say blame the water treater. You really have developed ways to get information. You've created alliances with people like myself and other people in AWT to test that information. And I know I personally have learned a tremendous amount because of that. So I want to thank you for doing that.
Well, that's very nice of you to say, Trace, and it's really my pleasure to be able to do that, not only individually, but on behalf of Evapco. And, I'd say that one of the great things about water treatment as an industry and a career is no matter how much you've done, there's always something else you can learn. And I've had the good fortune of learning a lot from my father and other people at Betts, as well as many of the people at AWT that are brilliant in specific parts of the industry. So if we all keep an open mind and are able to ask questions and learn from each other, I think we're going to move the industry in a positive direction.
Well, I can't think of a better way to close this segment. So thank you so much for coming on and sharing all these ideas. I'm definitely going to get all the items that you mentioned up on my show notes page. And you've been a great guest. Thanks again.
Thank you, Trace. It's been a pleasure. Thanks for having me.
I am amazed at what happens when people team up to solve a problem instead of simply pointing fingers at each other. I've really enjoyed working with Chris and Evapco and sharing my data that I've collected over the years on white rust, and then in turn sharing what they have with me. Collectively, they have done so much for learning what causes white rust and how we can do better jobs in working together with the manufacturers so we can prevent white rust. I gotta say, I hope that next time when you have an issue, your first goal will be to work with the people that are involved to solve the issue and not try to assign blame to somebody else. It's my hope that you use tomorrow to make yourself a better water treater than you were today. And I look forward to listening with you on the next episode of Scaling Up. Have a great week, folks.